Okay, hey guys, just going into our last live stream here. I'm going to wait a couple minutes and see how many people show up, but this is going to be the last one. Exam is tomorrow. Let me just see here. Exam is tomorrow at 9 a.m. I'm going to let you guys know what room you're in, but I'm just going to wait a couple minutes and see if anybody else comes in here. As I was saying to you guys at the tutorial today, that this is a question and answer. Hey, Brooke. This is a question and answer session, so I am going to go over a couple of things here really quickly. But first, I want you to start typing your questions right away because there's a lag, like a pretty serious lag between when you guys are typing, like from when I'm talking to when you guys are typing. So if you have questions, start writing them right away. Oh, Julie says she has a list of questions for me. Perfect. Okay, so start typing in questions. Really quickly, I'm just going to go over this document, which is what I gave you guys last week on our last day of class. I just want to remind you of this because people were asking me about this in class today. Okay, so there's different weightings here for the different parts of what we learned so far. Okay, so like content area, there's a weighting. So living world, which is everything we learned about the human body, that's 36% of what you're going to need to know for your exam. There's 5 multiple choice questions, 4 short answer questions about the living world, so about the body. As you see, part C, like I've been telling you guys, is called the technological world. So there's all of the questions in part C are tech questions, okay? So there's no like long answer questions about the living world or the material world. I need you guys to realize, like everyone keeps asking me about part C long answer, that in your history and math exams, part C is always a long answer thing. But like I said, for science, it's just a tech analysis. Okay, so Julia is asking me what are speed changes. So if it's talking about speed change, it's really talking about going from one size of gear to another. Okay, so like anytime you have, like if we have, sorry, here, I'm going to switch to the camera in a second and I'll go over that in a second. I just want to tell you, it's great that you guys are typing your questions. I just want to tell you what rooms you guys are in first, okay? So this was the breakdown of what's on the exam. Email me if you're concerned about anything more on this. I just wanted to tell you guys, last thing, that the rooms that you're writing in, so people who are in my homeroom, you're writing in 306. People who are in my small class, which you guys know which class that is, you're in 307, and enriched are in 314. Even if you're writing in resource, you have to go to your class right away and listen to the instructions, okay? So I'm just going to minimize this here and go over to the camera so I can explain the things you're asking about. Just kidding, it's not working. There we go. Okay, so, so right away, first thing, Julie was asking about speed change. So if we're talking about speed change, really it's like if you're going from a large gear with 1, 2, 3, 4, 5, 6, 7, 8. If you're going from a large gear to a smaller gear, okay, this transfer of speed from here to here is going to be going faster, because speed we can talk about in revolutions per minute, which is RPM, okay? And a smaller gear will not take as long to spin around. So there will be more revolutions per minute in a smaller gear than in a large gear, okay? So that is why that speed change happens. But there's actually a ratio, and you can do it based on the size of the gears, or you can do it based on the number of teeth that are involved here. So in this one has 8 teeth. This one has 4 teeth. So you actually have to divide this. So when you go from 8 to 4, that is 8 divided by 4 is 2. So this one is going twice as fast as the large one. Okay, so that's what it's talking about with speed. I don't think they're going to ask you to calculate speed. I think they're going to ask you in which direction it was transferred, if something is making it going faster or slower. Okay, so the larger the gear or wheel, the slower it will go. The smaller ones go faster. Okay, next question. So Callista is saying, can you explain the digestive tract? Absorption of nutrients, water, and elimination of waste. Okay, so digestive tract, I guess I'm just going to draw a little picture for us here. Okay, so your digestive tract is the path that your food actually takes through your body, okay? So I'll just draw us a little person here. This is going to be beautiful. Oh, yeah. There we go. Okay, so perfect. Okay, so your digestive tract starts in your mouth. Let's just say this is your mouth because it's not a very good drawing. Starts in your mouth. Okay, you chew your food, break it down, turn it into a food bolus. I just realized you guys can't see. Okay, you turn your food into a food bolus. It goes, when you swallow it, through your pharynx, but really we don't mention much about the pharynx here. It goes down your esophagus to your stomach. So your stomach's on this side. Okay, then there's some other organs involved here because you guys know that the liver is here and whatever, but like the liver is up here. But your food doesn't actually go into your liver, okay? Your food goes from your stomach, it goes into your small intestine. So your small intestine goes all over the place, okay? It goes all over, it's really, really long. And then your small intestine passes it into a larger intestine, so the big one, that also carries it around, okay? And then your large intestine ends up coming down and forming your rectum and your anus. Okay? That is the tract that your food follows. So mouth, esophagus, stomach, small intestine, then large intestine, rectum, which is, you can consider it part of your large intestine, and anus. Okay, that's the path that your food follows through your body. The other things like your liver, your gallbladder, your pancreas, which is under here, all of those things are part of the digestive system, but they're glands. Because what they do, the food doesn't actually travel through them, but what they do is they produce things that are going to be secreted, so like dumped into the small intestine. So your liver makes bile. So this is not part of the tract, it's part of the glands, okay? Liver makes bile, okay, for breaking down fats. Your stomach has glands in there. So you have gastric glands inside your stomach that are kind of like secreting gastric juices into there to break down protein. So your stomach breaks down protein. There's starches being broken down in your mouth by your salivary glands. So saliva breaks down starch, which is kind of like carbs, but it's like complex carbs. So like rice and potato and stuff like that starts to get broken down in your mouth. Okay, then your bile gets dumped into your small intestine. So right here, after the food is passing from your stomach into your small intestine, your bile is also getting dumped into there by your liver, and your pancreas is dumping pancreatic juice into your small intestine as well. Okay, so all of those things are going into there, and there's juices in your small intestine too. And then that really is where most of the breaking down happens. Okay, so once all of that breaking down has been done, the absorption, so actually sucking up the nutrients, is done with the, all right here, absorption is done by the villi, which are inside the small intestine. Okay, so almost all of the nutrients are absorbed inside your small intestine. So the nutrients we talked about, and I'm going to say the ones that actually get absorbed in there, would be protein, carbs, fats, vitamins, and minerals. But the only one that gets absorbed in the large intestine is water. Okay, so water, I'll just write under here. Large intestine. Okay, and then you compact everything that's left into fecal matter in your large intestine to exit the body. Okay, so hopefully that's enough of an overview for your digestive system here. I'm just going to go up and see what follow-up questions people have had here. People are typing a bunch of questions, which is awesome. Okay, what's the difference between the central nervous system and the peripheral nervous system? Okay, I'm just going to quickly skip to Callista's question that was after that because it's about digestive again. So can you describe the function of the main organism, organs, I guess, that make up the digestive tract, mouth, stomach, small intestine, and large intestine? Okay, I think that's what I just did. Yeah, I just did all that. Okay, hopefully that's okay. Callista, if that's not okay, then write underneath that you need me to go over it more, or you can send me an email, okay? Okay, yeah, so Julie asked, what's the difference between the central nervous system and the peripheral nervous system? Hopefully these pictures that I'm making are okay to go over this because it would take me too long to bust out my notes about everything. Okay, so I'm going to make us another little picture. I feel like my camera's frozen a little bit here. Whatever. Okay, so in your body, first of all, your nervous system is like your brain, your spinal cord, and all your other nerves. So like you have nerves in your whole body. Okay? You have nerves and neurons passing through your whole body. All of your nerves, whether it's in your brain or your central nervous system or your peripheral nervous system, they're all made up of neurons. So a neuron looks like this. Okay, so I'll just draw one out for you. There's a cell body like that could be called a soma. Okay? There's these dendrite things here, which pick up information, and then it's carried down this thing called an axon and dumped out at the end into a space before it gets picked up into the next one, okay? And then it just keeps going in that direction. All right, so this is called the axon. This is called cell body. This is called dendrite. Okay, and then this space here where it gets dumped into is called a synapse. Okay, everything in the nervous system is made up of these neurons. That's how the information is transmitted. Okay, so that's a neuron. But then other than that, you have millions, billions, billions of these inside your body. But like what's making up the whole system? Well, the part that's actually driving the functions of your whole body is your central nervous system. Okay, so your central nervous system is just your brain and your spinal cord. So if I draw out a little person again here, these pictures are ridiculous, I'm aware of that. Pretty sure I will never end up being your art teacher. Okay? So for this person, their brain, which is inside their skull, and their spinal cord, which runs all the way through your vertebrae, those are the two parts that actually make up the CNS. Okay, then beyond that, peripheral means to the sides. So any other nerves in your body, so these are the only ones allowed making decisions. Your brain makes decisions of like everything. The only time your spinal cord is allowed to make a decision is in the case of a reflex, which we've looked at quite a bit. So it means that there was a danger and you had to act quickly. So your spinal cord is allowed to make decisions about that, and you can just move really quickly. It's kind of an involuntary movement. Okay? So that's the central nervous system. Peripheral nervous system is like the fact that in between, you know how in each of your vertebrae, so the bones in your back, there's like holes on the side from when we were looking at Skelly? That's because there's nerves coming in and out of like every single notch in your spinal cord, okay, in your spinal column, and they're going to the other areas that are around. So there's ones going in your arms and legs, like a lot of them, going everywhere in your abdomen because they have to go to your organs that are in your abdomen. Like you, whether you realize it or not, your brain has to tell your organs to do things. So you're like, even the fact that we were just talking about your liver and your stomach and whatever, those organs are not going to do anything without the brain telling them what to do. Okay, so like these nerves are taking information to the organs and bringing it from the organs to your brain as well. Okay, so like to be able to communicate with the brain, you have this peripheral nervous system going all over your whole body. Okay, so peripheral nervous system is the nerves everywhere else. In your body. Okay, and they cannot communicate directly with the brain. Notice that there are some nerves inside your head, like there would be nerves in your face and like in the top of your head, like on top of your, you know how like you can feel something touching your head? The fact that you can feel things touching your head is because there are receptors in the skin on your head as well. So like those ones wouldn't need to go through the spinal column to get to your brain because they're close enough, they're already in your head. But everything else, so that's why we talk about like these ones cannot communicate directly with your brain. So they have to travel through your spinal cord to get to your brain, which is why people can get paralyzed if they injure their spinal cord, because if they can't get messages from the rest of the body to their brain, then it's a huge problem. Okay, last thing I'm going to say for this, that for sensory versus motor nerves, so sensory nerve goes from your sense, so from your senses to your brain. So whether that's like something touching you, so picking up something on your skin, it could be picking up taste, it could be information from your retina that's being like showing you what you're able to see in front of your face. All of that on the way to your brain is being carried by a sensory nerve. Once you're in your brain and you would like to decide to tell your body to do something, that's called a motor nerve. So motor nerve goes from brain to like your body or your muscles. Normally it would be to a muscle because your muscles are the things that are actually going to make you like do something. So whether it's inside an organ or inside like one of your limbs or whatever, like you need to be able to tell your muscles to do something in order to create some kind of change. Okay, so that's the difference between sensory nerve and motor nerve. All right, so hopefully that's enough for the nervous system. All right, so let me see what else we got here. Okay, there's questions. Those questions were about the digestive system, which I answered. Okay, Kate is saying on the checklist, it says that we need to be able to explain the roles of the lungs, kidneys, and sweat glands in maintaining a balanced metabolism. Does that mean getting rid of waste? Yes, that's exactly what that's talking about. So we talked about, when we talked about, hold on a second. Okay, another page. When we talked about the excretory system, okay, we went into detail about the urinary system. So that's your kidneys. Okay, but we also named the fact that there were other ones. Okay, so there's like your skin, there's something called your integumentary system, which is your skin. And what you do to get rid of waste in that case is sweat. So your sweat glands are part of your integumentary system for you to be able to get rid of waste in that way. Your lungs are also performing. So this is like, all of this is talking about get rid of waste. Okay, your lungs would be doing that as well. So your lungs would be getting rid of CO2. All right, your kidneys are getting rid of urine, so urea. And then the other thing would be your large intestine or your rectum. Which is getting rid of fecal matter, which we had already talked about, so we didn't go into a lot of detail. We focused on the urinary system. But yeah, you would have to, like you saw in the practice exam that we had today, the question that was about your sweat glands was basically just saying, like, they just told you that you were getting rid of sweat, and they asked you, it was a question that they asked about evaporation. So they were asking you, like, when your sweat is evaporating, so that's going from a liquid to a gas, you had to match it up with the particle model, okay? But yes, these are the 4 parts of the excretory system that we had talked about, okay? So let me just see. And that's how you're keeping a balanced metabolism, is that you're like taking in new things and bringing nutrients and oxygen into your body, but you're also getting rid of waste. Otherwise, if you're maintaining too much waste inside your body, it's not going to be good for you, okay? All right, so next one says, what are the parts of the skeletal system? I think the thorax was a part of it, but what even is a thorax? Okay, so I don't know if I could draw out a whole skeleton on here, but your thorax is just your chest cavity. Okay, so we had the 3 parts were the head, the trunk, and the limbs. Okay, so like within your head, you had your cranium and then facial bones. Within your trunk, you have your vertebrae. Okay, and then you have your ribs, so your rib cage. But your rib cage, so this your vertebrae are like those little bones that we used to, you know, like we normally in layman's terms would call it your spine, but your spine is actually the nerves that are inside, okay? So like that column of bones around your spine is called vertebrae. Your rib cage would also be called, okay, like thoracic cavity. So when they're talking about thorax, they're talking about your rib cage, okay? And then your limbs would be your arms and your legs. And in the middle here, honestly, like your pelvis could go into either category here, because your pelvis is like, it's protecting it's like providing the frame of the bottom part of your body, but it is also like part of, like it is the top of your legs. So it could fall into either one of those categories. Like it could make an argument for either one, okay? But your pelvis is like, the pelvis in men and women is different, and that's the part where we can tell the difference in their skeleton. So if we find the remains of somebody, it's the pelvis that tells us whether it was a man or a woman, but only if it's a woman after puberty, because little kids have the same skeleton, and then during puberty, your bones actually change. So the hip bones on a woman actually like change form during puberty, because in theory at some point you are going to have to pass a baby through your pelvis. Okay, so those bones have to shift to be able to do that. Okay, so I hope that's enough for explaining what the thorax is. For the skeletal system, you just need to be able to like understand the functions of these different parts. So like what they're protecting. I'm pretty sure you guys know that your cranium is protecting your brain. Your trunk is protecting so your vertebrae would be protecting your spinal cord. Your rib cage would be protecting your heart and your lungs. And then your limbs are just supposed to be like, that's not really to protect anything, it's to provide structure for movement. So your skeletal system provides structure for you to be able to move. Otherwise, as we talked about, you would just be like a pile of organs on the ground. Your skeleton is what gives you your structure. On top of that, within your bone marrow, you make new blood cells inside your bone marrow. Okay? All right, I'm going to move on to the next one here. What exactly is urea? Okay, so it's like when you're in your excretory system, so I can go back to that. Okay, in your urinary system, you have your kidneys. Then there's ureters, which are tubes carrying waste from your kidneys. Then it goes to the bladder, which is where you store your urine. And then the last thing is your urethra, which is where your urine exits body. Okay? But what's happening is that your blood is like, while it's circulating in your whole body, it passes through your kidneys, and your kidneys are doing a job of taking the waste out of your blood. So there's like a bunch of things in there. There's like, could be like excess minerals. It could be like nitrogen. It could also, so I'm just going to write, this is what urea is made of. Okay? It could also be made up of like, if you have hormones in your blood, if you have medication, like remnants of medication, or if it was like toxins from alcohol or drugs, all of those things are being pulled out of your blood in your kidneys and creating this urea substance. Okay? And then it's mixed together with water. So it's urea plus water, and that's what's making up your urine. Okay? So like if you don't have enough water in your urine, it will be very, very yellow because of the urea. The urea is what gives like the yellow tint and also the odor to your urine. Okay? But the rest is made up of water. And it would just depend on the levels that are in there, like this, what color your urine is. Okay? Next one. Do we need to memorize the whole nervous and sense thing, or is it more of a thing you just need? Wait. Whoa. Sorry, my screen jumped all the way down. A thing you just need to understand. Yeah, it's just something you need to understand. You definitely do not need to memorize where all your nerves are or anything like that. You just need to understand that your central nervous system, so the part that's allowed to make decisions, is just your brain and your spinal cord. Okay, you just need to understand that. Yeah. Okay, Kate is asking, can you go over the last 2 points of the waves section of the checklist? Yeah, okay, 1 second. So checklist is here. Okay, so this is where I had been drawing on here when we were doing it yesterday. So I can determine the focal point of a concave and a convex lens. Okay, so you would need to be able to determine like what's happening with concave and convex lenses. So here I had already drawn this when we were talking about it yesterday, and it says I can describe the relationship between the focal point of a lens and the degree of the deviation of light rays in different situations. Okay, so like when it's really concave like this, when the light comes in here, it's going to try and focus it like on here, okay? Like, but somebody who has myopia, they need to get diverging, which is convex, lenses to be able to correct this. Somebody who has hyperopia has to do the opposite. They need concave lenses in their glasses to be able to correct that, okay? So you need to be able to understand where this focal point is going on here. And the other thing is that for convex lenses, so concave will kind of like refract it downwards in like this, okay? If you have convex lenses, that when the light comes in here, it's going to be refracted the other way. So it's not actually doing a job of pulling the light together. It's like splitting it apart. Okay, so that's like in both cases, this is refraction that's happening. But in this case, when it's round like this, it's pulling them together. When they're facing opposite directions, it's splitting the focal point apart. Okay, so there should be slides on that in the second set of slides that we have on waves. If you want to flip through there, there's like actually nice drawings that are explaining how this works. Okay, but that's pretty much it. Like refraction, like we said, is when you're passing from one transparent medium to another, which actually happens with your eyes because it's passing through the air and then it's passing through your lens. So that's a different transparent medium. And our lenses in our eye actually are concave ones, so that's the impact that it's going to have on there. It's like splitting, it's bringing the focal point closer together, okay? But in a magnifying glass or something, you would have convex lenses like this, and it would actually spread the focal point apart, and that would project the image larger, okay? All right, next question here. Cool, my camera stopped working. Hold on a sec. All right. Can you explain can associate food with their main sources? Okay. So you need to be able to match up. There's a lot of practice questions that we saw where they would name you a bunch of foods, or they would say like, they would give you some kind of menu. Okay, and then they're gonna say like, figure out the best option for building muscle or something like that. Okay, so you need to be able to know what the 6 kinds of nutrients are and what they're kind of good for, like just in a very general sense. So if you need to know that protein is good for building muscle, and you would need to be able to, like, out of a menu, be able to say that things that have meat or like legumes, so beans, would be protein. So you'd have to be able to choose like chicken, fish, lamb, or whatever, like something from a list of food sources they're going to give you. So you would need to know all these, and that it would be like, you could have chickpeas or some other kind of bean, okay? So you need to be able to line those up, but so you need to know protein, you need to know that carbs are generally for energy. So if you're trying to like build energy, you would have carbs, okay? And this would be like bread, pasta, also veggies and fruits, okay? So all of those things are carbs. These ones are more complex carbs. These ones are simple carbs, all right? And then the other one that gives us energy would be fats. Fats would be like, well, really like the reason you would want to have fats in your diet, they just might ask you which one of these has a high fat content, but the reason you would want to have fat in your diet is for like insulating and protecting organs. Okay, but the kinds of foods that have fat, the good kinds of foods are oils, or like avocado or something like that. Okay, And then the less good ones would be like butter, okay, or like French fries. So all of these have energy. The other three are still essential, but they don't give us energy. So you have water. I don't really need to give you an example for water. It's just water, okay? You have vitamins, and you have minerals. So when they're asking you, if they were asking you to choose a food that had vitamins and minerals, you should go to like veggies. I would definitely pick veggies. If there's like broccoli there or something, I would choose that. But I don't think they're going to ask you this. I think they're going to ask you something like to match up these kinds of things. And the only other thing was that bananas, which are high in potassium, even though those are just part of like carbs, I guess, they have a lot of potassium and they help with muscle pain. So you could choose bananas if it's talking about muscles. Okay? So we need to be able to know that for different kinds of foods. You'll have to match that up. All right, so Julia's saying, hey, miss, can you explain how the excretory system plays a role with maintaining a balanced metabolism? Okay, so that was what I was just explaining. Over here, I kind of said that because that was what Kate's question was too. So like your whole point of your excretory system is to get rid of waste, but keeping a balanced metabolism means that you're keeping a constant like balance from what's coming into your body and what's going out of your body. Okay, so while you're breathing in oxygen and you're taking in like you're also taking in heat from the outside world. So like the fact that like your body would heat up, like you getting rid of sweat is also you maintaining your metabolism, because like your things are coming into your body, whether it's through like eating them, through breathing, through like the fact that there's heat coming into your body. All of these things that are getting rid of some kind of waste are helping you like maintain a metabolism. So it's helping you keep your levels normal inside your blood, and it's helping you maintain a proper temperature. So your skin, like the fact that your sweat glands are getting rid of sweat is making it so that you keep the proper temperature in your body. Okay, so those two things going together, like keeping the appropriate levels of different chemicals inside your body, like your excretory system is helping you maintain that. So whether it's your urinary system, your sweat glands, your lungs for getting rid of CO2, or your large intestine for getting rid of fecal matter. Okay, all of that helps your metabolism. All right, Kate says, this has nothing to do with the exam, but where do we bring our textbook tomorrow if we still have them? Please bring your textbook to class if you still have it, and just pile them up at the front, because I'm going to be passing by, like, just so you know, even if you get there and you're not sure about something right away, me and Mr. O'Brien will be walking around between all of you guys' exams the whole time. So just bring your textbooks to class and I'll pick them up, okay? Okay, Callista is saying, can you explain the role of the kidney, lungs, and sweat glands in maintaining a balanced metabolism? Okay, I just answered that. I've done that 2 or 3 times now, so that's fine. Next one. I can explain, can associate nerves with the transmission of nerve impulses. So that's what I was talking about before, about being able to associate which nerve is doing what. So like if you're going, the classic question that we have is where they're doing the knee-jerk reflex thing. So when you hit your knee with the hammer, on the way up, it's a sensory nerve that's carrying the impulse. And on the way back down, it's a motor nerve. So you just need to know sensory versus motor. So sensory is from the outside to your brain. Motor is from your brain to your muscles to be able to do something. Okay? But yeah, just remember that in the knee-jerk test, it doesn't go all the way to your brain. It's being decided in your spinal cord. Okay? Okay, so Brooke is saying, can you go over focal points and lenses? Okay, that's what I just did in the last one. John, do you know what room we are in for the exams? Will there be a sheet or something to tell us? There's a sheet to tell you for sure, but I said it right at the beginning here because everybody's writing the 300s. Where did I write this? Hold on. My homeroom, so John, you're in my homeroom, that's in 306. People who are in my small class, it's in 307. And people who are in the enriched class, you guys are in 314. Okay? All right, what else? Callista's saying, can you explain the functions of the main parts of the skeleton? Okay, so the skeleton, like I was saying on here, you have your head, which is your cranium and your facial bones. You have your trunk, which is your vertebrae and your rib cage. And you have your limbs, which is your arms and legs. So here are the functions. Okay, like they would be protecting your brain. And your facial bones would be like providing structure of your face. And your mandible, which is your jawbone, makes it so that you're able to talk and able to eat and everything like that. Okay? Your trunk, here you would be protecting. So in your vertebrae, you're protecting spinal column, your spinal cord. You would also be protecting your lungs and your heart. Okay, and you're making it so that you can stand up straight. So your vertebrae is like the whole column going up your whole back. So without that, you wouldn't really be able to stand up. Okay? Then your limbs are doing providing mobility, so making it so that you're able to move around. Okay? But like, I think when they're asking you about the functions, like all of these things are functions of your skeletal system, but like overall the functions are providing structure to your body. Okay? Facilitating movement. And protecting vital organs. So specifically your brain, like it's protecting a lot of your organs, but like being able to protect your brain, your heart, and your lungs from like the outside world is pretty important for your skeleton to be doing. Okay? Next one. What organs do they protect? Oh, perfect. Okay, that's what I was just saying. Julian's saying, John, there is a sheet in front of the office that will tell you. So they're in front of the main office. Yeah, I told you guys the classrooms anyways, but there is a list in front of the main office telling you where you can go for your exams. But everybody in grade 9 is writing, like, basically from Mr. Auger's room to the end of the science hallway, all of the grade 9 exams are in there, so you'll be able to figure it out. Okay? Okay, so the next one says, can you go over the question of reproduction on the checklist? Oh, and John's saying, okay, thanks, my dog, Julian. That's awesome. With a weird face. Great. Okay, so let me just go over to the reproductive section here. Okay, so you do need to know meiosis and mitosis, which was part of what we learned in the reproductive section, but it was part of cell division. So you need to know that mitosis is for reproduction of cells, it's for growth, and for regeneration of broken down tissue. And that you end up having copies that have the same, like they have 46 chromosomes to start, and the copies are identical because they have 46 chromosomes too. Okay? Then the only other one, meiosis, this one only has one job, meiosis. That's production of gametes, which are your sex cells, so your sperm or your ovum. So if you end up, I think what will happen is that you'll end up with a multiple choice question. It could be in section B, but I think it would probably be multiple choice. And they would be asking you to match up the functions of mitosis or meiosis. So you need to be able to do that. because it even says I can distinguish between mitosis and meiosis based on their functions. So I think there'll be a question and it'll say like, which one of these is not the function of mitosis? And your 4 options would be exactly this: reproduction of cells, growth, regeneration of damaged tissue, and production of gametes. And you'd have to say production of gametes is the wrong one because that's meiosis. Okay? Below that, where it's talking about the actual reproductive system, the only point they gave us for the checklist is I can name the hormones responsible for the formation of spermatozoa, which is sperm. Okay? Like we went over the other day, you have FSH and LH, which are present in both male and female. Okay? It comes from your pituitary gland, which is at the base of your brain. Those hormones are being stimulated during puberty, and they stimulate sex cells to start being produced, and they stimulate like your sex hormones coming out of your reproductive organs. Okay? So these ones are coming out of your brain. But then testosterone is being emitted in males in the testes to encourage sperm production. All right? Estrogen and progesterone, those are the female hormones for ovulation and menstruation. Okay, so I don't know if it will be a short answer question or a multiple choice question, but it's specifically telling us that it's going to be about spermatozoa and that you would have to be able to say FSH, LH, and testosterone. So if you get a multiple choice question about this and it says estrogen or progesterone, those ones are wrong. So those ones have nothing to do with sperm. Those are to do with ovulation and menstruation. Okay? There was nothing else from nothing else from reproductive. All right. Give me a second here. I just got to go back up in the question list. Okay. Kayla, can you do the nervous system and lymphatic, please? Can you also do a density question with the conversion needed, please? Okay. I already went over the whole nervous system, so if you weren't here for that part, then you can go back and watch that afterwards because we went over the nervous system. But I can go over lymphatic for what you would need to know for lymphatic. So here. Okay, so lymphatic. All we need to know for lymphatic is that it's supporting your circulatory system. Whoa. Because there's 2 things that come out of your circulatory system when you get to the capillaries. Because there's holes in there, you have plasma leaks out, and you also have white blood cells change shape to exit. Let me just check on the checklist what it says for lymphatic before I tell you all this stuff, and you don't need to know it all. Hold on. Okay, yeah, all it says from your checklist is I can describe the two ways of acquiring active immunity. So production of antibodies as a result of illness or vaccination. Okay, so all it's talking about is all you need to know really is that your white blood cells, their job is to protect body against infections. Okay? So what you need to know is how they go about fighting infections. So there's 2 ways, like the 2 things that they can use are the antibodies, okay, which are the little Y things that we saw in the Magic School Bus. Okay, so they can throw these Ys at the antigen, or they can do phagocytosis, which is like when they swallow the antigen whole. Okay, those are the 2 things that it can do to be able to fight off an infection while it's there. But the ways of acquiring immunity, okay? So for you to be immune to a disease, that means that you have the antibodies, okay? So immune means you can't get it again. Okay, and the two ways of us becoming immune is one, we already had it. So now we already have the antibodies, because once you make these antibodies, you don't need to make them again. Your body already knows how to fight that infection, so you hold on to that. So now we have antibodies ready for that. Okay, so this would be like naturally by having an illness. That's the first one they're talking about. The second one, your other option, is through a vaccine. So this one happens naturally. This is through a medical intervention. So a vaccine, like we talked about, you take a little piece, you take a little bit of that infection and they inject it into you, but like not a strong strain of it, just a very weak one. And then again, you build those antibodies, you fight off the infection when it's really weak. So then now you have antibodies, and if it comes back, you already know how to fight it. So again, you already have antibodies. Okay, so then in that case, if you ever come in contact with that infection again, it can become active in your body for a very short time, but it won't have any symptoms manifesting because you've already fought off that infection. Okay? Well, let me keep going here. This is a long video, you guys. Okay, Kayla also wanted me to do a density question. So let me see here. My computer is going like so slow. I feel like it's going to explode or something. Okay, density equals mass over volume. Sorry. So a case where you would have to do a conversion is if they wanted you to write your answer in grams per liter, but then they said you have like, I don't know, I'll just make up some numbers. So the mass, you have 20 grams per every 500 milliliters. So you would have to realize that 500 milliliters is 0.5 liters. Okay, so how you would do that is just divide by 1,000. Okay, so if you had 500, if you divide by 1,000, you get 0.5 liters, and then you would still just plug in. So the M over V, you would put 20 over 0.5, so you should get 40 grams per liter. Okay. All right, so that's fine for density. The next one said, can you describe the effect of variation in temperature on the solubility of a substance? Okay, yeah, so the effect, all that you need to know is that when temperature increases, solubility also increases. Okay, that's all you have to be able to mark down. You don't have to calculate solubility in any way. You just have to be able to explain what the relationship would be. So if it got hotter, there would be a higher level of solubility. John says, man, there's a lot of questions. I totally agree, John. This is taking forever. It's all right though. Keep them coming. I'll answer all of them. I don't want you guys to be freaking out. Okay, next one says, explain how fluids move around in the human body using the concept of pressure. Okay, so for that, there's two kinds of fluids. Okay, you have compressible and incompressible. So this would be a gas, and this would be a liquid. So the examples from your body for compressible would be oxygen or carbon dioxide. So you would have to be able to explain what's going on with like pressure and volume in your lungs. Okay, so you would have to be able to say that when you breathe in, the volume of your lungs increases and the pressure in your lungs decreases. Okay, so you need to be able to explain that relationship and how inhalation and exhalation works with pressure and volume. I think it's going to be this question. I don't think they're going to ask you the incompressible fluid one, but just to be clear, the incompressible would be blood. And you would have to say that, like, when your heart pumps, it's kind of decreasing volume. So it squeezes your blood out into your blood vessels. So into your arteries. Okay, you would just have to talk about the pressure inside your arteries and how it pushes your blood around your body. Okay, so that's what it's talking about when it's talking about pressure inside your body. All right, next one. Can you explain the difference between saturated and unsaturated? Are you talking about when you're saying saturated versus unsaturated? Are you talking about in fats or are you talking about in solubility? I'm just going to wait for Brooke to answer about that, but I'll check somebody else's question here. Oh, I thought we were almost done here. There's so much more. Can I do a concentration example? Then there's a bunch of questions retracted. And John's saying, I don't want you to be freaking out. Thank you. I'm not freaking out. I got this because I don't have to write an exam tomorrow. It's you guys. I just got to walk around and support you guys. Kayla said, I just realized we're using the same pen. Cool. Thanks, Kayla. Great. Okay, so I only have a couple more questions here. You guys can type them in. I'm just waiting to see if Brooke can tell me, like, I don't know, because there's two situations where we talked about saturated and unsaturated. We talked about saturated and unsaturated fats, but we also talked about that with reference to solubility, so I'm just not sure what you're talking about. Okay, yeah, so Gabby wants me to do a concentration example, so I'll just do that while we're waiting to see which one Brooke was looking for. Just use a ton of paper, it's no big deal. All right, so concentration is basically the same calculation as density. So like, whoa. The concentration of something, they would say like you're trying to make, they could say like you're trying to make a 5 grams per liter solution. And you have, whoa. Just getting messages on my screen, that's cool. And you have, so if you're trying to make this kind of solution, and you already know that you have like, you're only using 100 milliliters of water. Okay, and then they would say like, how many grams do you put in? Okay, so what what you have to plug it into is concentration equals mass over volume. Okay, so you want your answer to be, you want to have, and we always put this over 1 when we're doing it like this, okay? So you would put 5 grams over 1 liter, and you would want to know what that is over 100 milliliters. The only problem is if it's 100 milliliters, okay, you would need to just convert this. So 100 milliliters, like I said, you would do it divided by 1,000, and it would give you 0.1 liters. Okay, so you have 5 grams over 1 liter. You're going to put equals X over 0.1 liters. Okay, and then you would just do 5 times 0.1 divided by 1. So you would need X equals 0.5 grams. That's how much you would put in there to have the right concentration. Okay, okay, so Brooke is saying about this, and I will go back to what you're talking about with the saturation afterwards, Brooke, but Brooke is also saying 5% means 5 grams per 100 milliliters. Yes, if the concentration is in, a lot of the time it's written in grams per liter, but it can be written in percent mass over volume, okay? If you see that, if it says like the concentration is 8% mass over volume, the 8% is 8 grams out of 100 milliliters, okay? Because percent always means 100. It's always out of 100 milliliters. So you'd have to be able to realize that you're supposed to be talking out of 100 milliliters when it does that. Okay? I'm just going to go back to the question that Brooke had about fats. So you were talking about fats? Yeah, okay. Saturated and unsaturated fats. So I'm trying to figure out where I wrote that in here. Okay. Within this, we had been talking about fats here. So I'll just write it underneath here. Unsaturated are the good fats. So that would be like oil or avocado. Generally speaking, it's oil-based, okay? Saturated fats, however, would be like bad. These ones are not as good for you. Okay? So that would be like butter. And then the ones that are really, really bad for you are called trans fats. Okay? And that would be like French fry grease. So that would be like when they're refrying things in the same oil over and over again. That's really bad for you. Okay? So those are the 3 kinds. I really don't think you need to know those though. I don't think that will be an issue. All right? What else did I miss here? Did I miss something here? Cool, my computer's frozen. I did a concentration example. Fats, okay, yeah. Okay, synthesis and decomposition. Okay, I'll go over synthesis and decomposition. Then people are talking about percent mass over volume. You guys are having a discussion about that. Okay, so I'll go over synthesis, decomposition. I'll explain pulmonary tract. And then Gwen is asking for me to go over chemical, mechanical, and radiation, please. Okay. All right, so I'll just do those, and then I think we're maybe going to have to cut it off after that, but whatever. I mean, keep typing if you have other questions, guys. It's fine. I just don't know how long my computer is going to last. It feels like it's going to blow up. Okay, so there's a few different kinds. Okay, but the ones that are on your checklist, there's synthesis. Whoa. And then there's decomposition. Okay, a synthesis is when you're taking two simple things or just combining simple things to make something complicated. Okay, so an example would be if I'm taking Na, so one sodium and one chlorine, and putting them together to make NaCl, which is actually table salt. Okay, putting those two things together, that would be a synthesis. Another example, when they're asking you to have real life examples, the real life example they're going to give you is photosynthesis. Okay? On the other side, decomposition is the opposite. So it's breaking down something complex into simple parts. Okay, so you would have your NaCl already. So we have salt, and we want to break it down. So we do a decomposition, and it ends up being sodium and chlorine. So now we've separated the pieces. The example from real life for this that we were talking about is cellular respiration. Okay, you don't need to know any more details about photosynthesis or cellular respiration. You just need to be able to assign whether they're a synthesis or a decomposition. Okay, let me just go back up here. So hopefully that's okay. John says, wow, this has been an hour live stream. Yeah, I know. Like, it's getting to be pretty long, especially if somebody's planning on rewatching it later. Okay. Kayla is saying, why milliliters? Okay, if it's in percent mass over volume, that's just what it is. That's just what the information means. So it says 5% means 5 grams per 100 milliliter. That's just what the percentage means, okay? So the percent means that it's over 100 and it's in milliliters. Okay, so I'm just going to answer the pulmonary tract. So Julio, I just want you to tell me really quick, are you talking about pulmonary circulation? So are you talking about it with your heart, or are you talking about where your air actually goes through your lungs and then passageways? Are you guys still connected? Because a lot of people are saying they got disconnected. Can you guys like type in and tell me if you're still connected or not? Okay, Julio's saying the pathways. Okay. Okay, so I guess I'm drawing another little picture here. Okay, you guys are still there. Awesome. Okay, so here's my little guy again. Okay, so when you breathe in, okay, you breathe in through your nose. Let's just pretend this is a nose. Okay? You breathe in through your nose. It goes into the back of your throat, kind of like behind your mouth. Okay, so it goes into here. It ends up going, it crosses over. This is called your pharynx, right? Your throat. That's the only overlap between your respiratory tract and your digestive tract. And then you have your epiglottis in here, okay? Which you guys remember is separating between breathing and eating. And if you mess that up, that's how you're going to choke, okay? Once it gets past that, so now that it's in your throat, you have the next part underneath the pharynx is called the larynx. This is where you have your vocal cords, okay? So those vibrate so that you can breathe. Then it goes down into the next place called your trachea. which is made out of rings of cartilage. And like we've said, that you could crush somebody's trachea and larynx. Like your larynx is pretty much where your Adam's apple is. So generally speaking, males have a larger larynx, and that's what makes for them to have a deeper voice, okay? Then underneath your trachea is kind of like the front part of your throat. You could feel those cartilage rings on your throat. It's possible to crush somebody's trachea and then they would not be able to breathe at all, okay? You would not be able to get any air. Your trachea then breaks off into two. When it splits into two, okay, now these are called your bronchi. At this point, the reason it's splitting off into two is because it's going into your two lungs. Okay, so you have to split off to go into those. Now this part is like on the inside of your lungs because your lungs are just like the blood vessels all around it, okay? In the bronchi, it splits into even smaller tubes everywhere, which are called bronchioles, okay? It's like tree branches. At the end of the bronchioles, you have grape kind of things in there, okay? And those are called your alveoli. And your alveoli are just full of capillaries because there's capillaries passing by there which were coming from your heart. So they're doing the pulmonary circulation. They're coming from your heart to your alveoli, and that's where they're sucking up oxygen and they're getting rid of carbon dioxide so that you can breathe out carbon dioxide. Okay, and then your blood carries the oxygen away, dumps the carbon dioxide, and then you breathe out. Okay, and the muscles involved here, there's your diaphragm underneath, which is regulating the volume of your lungs for you to be able to inhale and exhale. So diaphragm. And there's also muscles in between your ribs. Okay, so those are called, can't really draw your ribs on here, but you have also intercostal muscles, which is between your ribs. And the reason for that is that you have to be able to expand and contract your rib cage for you to be able to like make your lungs expand. Okay? Hopefully that's okay for the tract. Let me see what else I was supposed to answer here. Okay, I can't scroll up anymore. Oh, yeah, I can. Hold on. Okay, yeah, so Gwen was asking me to go over chemical, mechanical, and radiation, please. Okay, so that's what I did in class today. We can just briefly go over it here. So let me just see, like, there's different kinds of energy. So chemical, whoa, you can't even see what I'm writing. Hate when that happens. Okay, so chemical would be like atoms and molecules. An example of that would be in your food. So when we eat food, we're trying to get those molecules, the like actual energy that's contained in those molecules, we're trying to get that into our cells for us to be able to use. Okay? So our food is an example of chemical energy. Another example would be like any kind of like gasoline has a bunch of atoms and molecules, a composition that we can use and break down and burn as fuel for our car. Okay, and then we change that into mechanical energy. So mechanical has to do with like physical force. So this would be anything to do with movement, whether it's in your body or an object. Okay, and what was the other one? Oh, radiant energy. Radiant is waves. Okay, so we have light waves. So there's light is a form of energy that's coming from waves. anything on the electromagnetic spectrum, all of that is different kinds of radiant waves. And we also use, so like the fact that we can turn on a light switch and have light coming out. So this is what we use for like our electricity kind of. Okay, and I'm just going to throw in the fourth one that was on your checklist since we're doing this. The only other one that was on there was thermal energy, which is heat. Okay, so like the hotter something is, the more energy. Okay, because the particles in something speed up when you heat it up. So that means that there's more movement in there, more energy contained in there. Okay, so I'll just pull this down so you can see them all at the same time. Okay. All right, so let me just see if there's any other questions right now. Okay, nobody else has typed any questions, so I'm just gonna kind of like leave this hanging for a second. Last like 15 seconds for you to be able to type a question. So just a reminder, you guys need a calculator for tomorrow. So you need pens and pencils, you need a calculator. It might be a good idea for you to bring a water bottle with you because it's going to be probably just as hot as today and you're going to be sitting there for 3 hours. Okay, but other than that, you don't really need anything else. You cannot have your phone on you while you're in there. So like if you forget and it's in your pocket, like if you don't want to leave it in your locker because you don't have a lock anymore, that's fine. Or if you forget, that's fine. But the teacher will say at the beginning, please bring your device up to my desk. Like go ahead and do that right away. You guys have to stay for an hour and a half. So once after an hour and a half, if you want to leave, you can. But before that, you can't. So you might want to bring a book or something, or you can just take a nap on your desk, whatever you want to do, but you can't go on your phone. Okay? So don't forget, you need a calculator, 9 o'clock, science wing. So you guys are in 306, 307, and 314. All right? It's been a pleasure. I'll see you tomorrow at your exam, and then you're moving on to grade 10. You got this. All right? Have a good night, you guys.